For decades, humans have imagined a future where robots walk, think, and work just like us. From science fiction movies to futuristic novels, humanoid robots were once nothing more than fantasy. But today, that future is no longer imaginary. It is real, and it is arriving faster than anyone expected. Around the world, engineers and scientists are racing to build robots that look human, move like humans, and perform human jobs. What was once confined to research labs is now stepping onto factory floors, warehouses, and industrial sites. At the center of this revolution is artificial intelligence, the technology that is giving robots the ability to learn, adapt, and make decisions on their own. As fears grow that AI may replace human workers, a global competition has begun. Tech giants, ambitious startups, and powerful governments are investing billions of dollars to win the humanoid robotics race. Companies like Tesla, Amazon-backed startups, NVIDIA-powered labs, and state-supported Chinese firms are all pushing forward. But one name continues to stand out as a leader in this space: Boston Dynamics. Boston Dynamics has spent decades redefining what robots can do. Known for creating machines that can walk, jump, balance, and adapt, the company is now focused on its most ambitious creation yet, a humanoid robot called Atlas. Atlas is not just another robot. It is designed to work in the real world, alongside humans. Standing nearly 6 feet tall and weighing about 200 pounds, Atlas is built to move with strength, balance, and precision. It can walk, run, lift objects, and navigate complex environments. But what truly sets Atlas apart is its brain. Unlike older robots that relied on fixed instructions written by engineers, Atlas is powered by advanced artificial intelligence. Using high-performance NVIDIA chips, Atlas processes massive amounts of data from cameras, sensors, and simulations. This allows it to understand its surroundings and learn from experience. In 2024, Atlas left the laboratory for the first real-world test. The location was Hyundai's massive new factory near Savannah, Georgia, one of the most advanced automotive plants on Earth. Inside this facility, more than 1,000 robots already work alongside nearly 1,500 humans, welding, stamping, and assembling vehicles with robotic precision. But hidden away in a quiet corner of the factory was something different, something new. Atlas was preparing for work. For the first time, a humanoid robot was being tested in a real industrial environment, not as a demonstration, not as a concept, but as a potential worker. Engineers watched closely as Atlas began sorting and moving car parts for the assembly line, completely autonomously. No human hands guided it. No one pressed buttons to control each movement. Atlas observed, decided, and acted on its own. This moment marked a turning point in robotics history. The man leading Atlas's development is mechanical engineer Zach Jakowski. With years of preparation behind him, this test represented more than just a technical milestone. It was proof that humanoid robots could finally move from theory into reality. But how does a robot actually learn to work? At Boston Dynamics headquarters, engineers use several methods to train Atlas. One approach is supervised learning. In this process, a human operator wears a virtual reality headset and directly controls Atlas's movements. Every motion, lifting, grabbing, placing, is recorded. That data is then used to train Atlas's AI models, allowing it to repeat the task independently later. Another method is even more remarkable. Using motion capture suits, engineers record the movements of real humans. Every step, every arm swing, every gesture is captured in precise detail. That information is then transferred into a digital simulation where thousands of virtual atlases practice the same movements over and over again. In these simulations, Atlas faces challenges like slippery floors, uneven surfaces, and mechanical limitations. The AI tests different strategies, learns what works best, and improves through trial and error, just like a human would. Once a skill is learned in simulation, it can be uploaded into the real robot. And here's the most powerful part. When one Atlas learns, all Atlases learn. Knowledge is shared instantly. Through this process, Atlas has learned to crawl, balance, lift objects, and perform complex motions that were once thought impossible for machines. It can even recover from falls, a task that requires extraordinary balance and coordination. Yet, despite these advances, engineers are honest about the limitations. Atlas cannot yet perform many simple daily human tasks. Pouring coffee, putting on clothes, or moving casually through a home environment remain extremely difficult. Human dexterity and intuition are still unmatched. But what has changed is something much more important. There is now a clear pathway forward. Thank God.
If we integrate the new cooling system here, we can increase output by 20%.
The data confirms the efficiency gains.
Move these boxes.
What is that thing?
It's incredible.
How is that possible?
Looks great. We're making significant progress. Look at the projected growth in the AI sector shown here.
Yes, demand for skilled technicians is skyrocketing.
Look at the balance.
Truly impressive engineering. This changes automation.
The age of humanoid robots has begun.
It's working. We finally did it.
All systems green. The core is active.
Atlas is online.